We'll now look at rational exponents. So in particular, when my exponent is a fraction. And we're going to start with the basic case of the exponent being 1 over a number. So 1/2, 1/3, 1/4, something like that. And this is equivalent to saying the nth root of a. So whenever I have a 1 over some number, it's actually the same thing as taking that root. Some examples. 9 to the 1/2 power would be the same thing as taking the square root of 9, which is 3. 27 to the 1/3 power would be the same thing as the cube root of 27, which is also 3. -8 to the 1/3 is the cube root of -8, which is -2. 81 to the 1/4 is the fourth root of 81, which is 3.
Sorry, I didn't get that.
This only considered roots with powers to the 1 over a number. But what if it's a generic fraction? A to the m over n. Well, this is the same thing as the nth root of a to the m. Or the nth root of a, all raised to the m power. So the denominator tells you what root that you should be taking, and the numerator tells you what power you should be taking. For example, 9 to the 3/2 power means I'm going to be taking a square root, since 2 is on the denominator, and then I'm going to be raising that to the 3rd power. The square root of 9 is 3, and 3 to the 3rd power is 27. -27 to the 4/3. Well, the 3 tells me I'm taking the cube root of -27 and then raising it to the 4th power. The cube root of -27 is -3 raised to the 4th power, which is 81. 32 to the -3/5 power. Since it's negative, this is the same thing as 1 over 32 to the 3/5 power. So now I have 1 over, the 5 tells me I'm taking a 5th root of 32, and then the 3 tells me I'm cubing it. The 5th root of 32 is 2, and then 2 cubed is 8. So this is 1 over 8. We can also use all of our old properties of exponents. So here, I would start with my first parenthesis. It's just x to the 1/3 y. My second one, I have this 1/2 power on the outside, so I multiply exponents. -3 times 1/2 is -3 over 2. And then 2 times 1/2 is 1. And I can now look individually at different letters. This will be x to the 1/3 minus 3 over 2. And then y to the 1 plus 1. This gives me x to the -7 over 6, y squared, which can also be written as y squared over x to the 7 over 6. Another example, this -4 means we're going to be multiplying exponents, so this is a 2 to the -4. 1/3 times -4 is -4/3. And then on the denominator, 1/2 times -4 is -2. We then like to make exponents positive, so the top becomes y squared. The denominator has an x to the -4/3. And we know that 2 to the 4th power is 16. And since it's a -4, it goes on the denominator. This is now positive since it moved to the denominator. Our last one, we should start by looking inside the parentheses first. So first we just have this 4. We want to subtract exponents when we divide. So 2/3 minus 3 would be -7 over 3. And then y, 1 minus 1/3 is 2/3, all to the 1/2 power. So I now have 4 to the 1/2, x to the -7/6, and y to the 1/3. Since we like negative exponents to be on the bottom, we'll move the x to the denominator, the y will stay on top, and 4 to the 1/2 power is 2.